Hello everyone, today we're looking at a sample vector question and we're going to solve a vector question by using the Cartesian method to determine the magnitude and direction of two concurrent vectors. The question now reads that a street fighter and Super Flash pulled Suzie-Kay's boat to shore. The street fighter pulled with a force of 85 newtons at 40 degrees above the negative x-axis, while Super Flash pulled with 70 newtons at 30 degrees above the positive x-axis, determining the magnitude and direction of the resultant force. Now, what is important, we're going to move from the picture form into the diagram form, which is a vector diagram. But just to recheck a little bit, I just want to show you that Suzie-Kay is being pulled in that way in terms of the pictorial form. But in terms of the vector diagram, we know, as stated, that the street fighter was pulling with 85 newtons above the x-axis at 40 degrees, while Super Flash was pulling with 70 newtons at 30 degrees above the positive x-axis. So this is the vector diagram for that information. Now, what we're going to do is to do a number of things to derive at our answer. Now, one of the very most important thing to do, or what I like to do, is to identify my forces. For example, I say force 1 and force 2. All right, to me, does make life easier. The next very thing you want to do is to look at your directions. Remember, in the Cartesian method, we look at our direction or angle from our positive x direction. So therefore, for force 1, this will be our direction or our angle. Now, to determine this, we already know that we have 40 degrees here. So the entire thing must be 140 because here will be 50, okay? And here will be 60. So 50 plus 60, that is 110, plus 30, that is 140 degrees from the positive x direction. Now, from we determine that, what is also important to do is to kind of break down the components for each force. So let's say we have our x component right here for force 1, and then we're going to have our y component for force 1. All right, let's do each at a time. So to break this down, we can simply say that force 1 in the x component, or the x component of force 1, which is this line, we can simply say that it is 85 newtons, which is the hypotenuse, all right, cos 140, and this equals to negative 65.11 I. Now, what is important here, we use 140 because this is the direction of this vector. However, you can use the 40 degrees, but you will get this value in a positive form. However, you have to remember that you have to put your negative sign there. So you could try to say 85 cos 40, you'll still get the same answer, but it will be a positive value, so you have to change it into the negative form. All right, so let's look at force 1 in the y component. So this will be 85 newtons sine 140, which equals to 54.64 J. Again, I represents the x and J represents the y component. All right, so that is for force 1. In terms of component form for force 1, what you're going to have here, again, remember, it is the sum of the I and J. So therefore, force 1 is minus 65.11 I plus 54.64 J. All right, so that's the component form for force 1. Let's look at force 2. For force 2, again, we have our x component and we also have our y component. So therefore, to express this in component form, we're going to say that force 2x, which is in the x component for force 2, is equal to 70 newtons here, which is the hypotenuse, multiplied by cos 30 degrees, because this is 30 degrees above the positive x, which equals to 60.62 I, or x, which is the x component. In terms of the y component for F2, we're going to say F2y equals to 70 multiplied by sine 30. Sine 30 is 0.5, so that multiplied by 70 is 35j, which is in the y component. Now, in terms of component form for these, for this force 2, what we're going to express this as is we're going to have F2 is equal to the sum of the two sides. So therefore, we have F2 is equal to 60.62 plus 35. And what I want to point out is why we say component form is because 60.62 and 35, they are portion of the F2 force, right? In other words, they make up the F2 force. That's why we call it the component form. They are components of, all right? And so again, I is X and J is Y. All right, once we have this, we can go further now in terms of calculation. And what we're going to do here is to kind of combine both vectors. And so in a combination form here, and still in the component form, what we're going to have is our resultant. So to combine them, what we get is the resultant of both forces. So in terms of component form, what I want you to understand and remember is that the resultant is equal to the sum of the I and the sum of the J's. And so we're going to kind of expand this a bit. So what in the expanded form, we're going to say the resultant equals to negative 65.11, which is the X component for force 1, plus 60.62, which is the X component for force 2, which is all I, plus those of the Y components. And so there we have our 54.64 plus our 35, and that is our J. All right, so once we had this up now, what we should get here is negative 4.49I plus 89.64 J. All right, and so that's the result of that calculation. Now, what we're going to do with this is actually identify what is X and what is Y. So again, in the negative X component, we have our 4.49, which is a negative. You notice that. And then for a Y component, what we'll have here is 89.64. So think about this as a resultant vector now, all right, or a combination of both vectors. Now, what we're going to do is to express this now in a graphical sense. And so what we're going to have here, in terms of a graphical representation, we're going to put our negative X component first. So we're going to travel in the negative X direction, where is negative 4.49 based on the graph. Then we're going to add our Y component. So our Y component. So in other words, you can think about it in this way. You go X first, then you go Y. Okay? So you're traveling X, and then you end up traveling Y. And so you have those two vectors represented like that. So the resultant now will be from this point where you start and to where you end. So that will be now our resultant vector, which is R. Now you can now use the mathematical concepts to find the resultant, which is now easy. Now, once you have this, it must be at an angle. So we could determine that angle as well, which is our direction. All right, so we're going to use 1, again, coming from the positive X, because remember now, all direction must be determined from the positive X using the Cartesian method. All right, so let's jump into some calculation. To find R, okay, it is the sum of the other two sides squared. So therefore, we're going to be negative 4.49 squared plus negative 89.64 squared. All right, and once you get that, you should get your answer as 89.75 newtons. I want to find our direction. So I want to find this angle. Okay, that's the easiest angle to find because we do not know what angle is here. So to find that angle, what you're going to do is to simply use tan, because we're going to use the opposite over adjacent. So the angle is equal to the inverse tan, 89.64 divided by 4.49. Again, we do not need to use the negative sign at this point, all right, because we just determine the direction or the angle or the unknown angle. So the negative sign, you could take that out at this point. All right, so as a result, you get 87 degrees north of west. And why north of west? Again, is because the angle is closest to west compared to north. All right, that's one way to represent your direction. And the way to do this, again, we look at our missing angle right here. So this, if this is 87, then here must be 3 degrees. And so we can also say 3 degrees west of north. All right, but in this Cartesian system, our direction from the positive X will be 93 degrees. Again, coming from here, it is 90, and then right here will be 3. to be 93 degrees from the positive x direction. All right, and so that's the magnitude and direction of resultant force for those two forces pulling by the Street Fighter and the Super Flash that were pulling Suzie-Kay's boat. All right, so I hope this was helpful, and I want to thank you for watching. And please remember, always look at things from the positive angle. All right, have a blessed and wonderful day. Talk to you soon.